Talk about this question. It says that a block is given an initial speed of 4.5 meter per second up on a plane which is 22 degrees of inclination. So how far will the up the will the block go, and how much time elapses before it returns to the starting position? And we have to ignore the friction. So it looks something like this. There is an inclined plane. This is 22 degrees, and this is the block to which we are given a speed of 4.5 meter per second. So the best way I would say to do is from the energy conservation, because there is one point where it's gonna go and stop. So the initial energy, which is only the kinetic energy, will be converted into the potential energy because it stops when it reaches at a particular distance. So half m 4.5 square is going to be mgh, where h is the height to which it has reached. So this vertical height is something which we are going to find from here. The m and m is cancelled, and the value of g is 9.8. So it's 9.8 h. So h is gonna be equal to 4.5 square over 2 times 9.8. So let me just grab my calculator here. So we have a 4.5 square 4.5 square over 2 over 9.8. So that's coming as 1.03. That's coming as 1.03. This is the required height. But we don't need the height. We need the distance along the plane which it has moved. So we are going to use a little bit of trigonometry here. So we are going to say that in this triangle, this is a triangle after all, and we need to find the value of s. So sine, we're going to use sine. So sine of 22 is going to be h over s. So s is going to be h over sine 22, and we already have the value of h, which is 1.03. So 1.03 over sine 22 is going to be the required value of the distance. So 1.03 over sine 22 is going to be equal to 2.75. So s is going to be 2.75 meters. So this is the answer to part A. For part B, we need to find the time which has elapsed before it returns to the starting position. So definitely, when it returns to the starting position, the best thing is it's going to follow the same path because there is no friction. So if the initial velocity was like this, then the final velocity is going to be with the same magnitude but in the opposite direction. So we're going to use the equation. That v is equal to u plus at. So from here we know the value of v, which is 4.5. We know the value of u, which is minus 4.5 because the vector is opposite, plus at. Now a is something on which we need to work on because the acceleration is only due to the gravity. So gravity is acting perpendicular, but along the plane it will have a component of g sine theta. So g sine theta is the acceleration. So g sine theta is something which you're going to put here, and this is the time. So time is going to be equal to 9 over g sine theta, where the value of theta is 22 degrees. So if you solve that, we let me grab my calculator here. 9 over 9.8 over sine 22. So it's going to be equal to 2.45. So it's going to take 2.45 seconds for this complete trip.